Hey everyone, today we are going to talk about automotive wiring. I've got spread out across this hood a gazillion different things that's going to get me started in the wiring project for the 57 panel. And I'm going to go through a lot of it with you, help you get started, and we're going to make this a job that's hopefully not intimidating. And if it's something that's in your future or could be in your future, you'll have hopefully a little bit more confidence to tackle it like I did. All right, so wiring. In most vehicles, you're going to have two different sizes of wires, primarily 14 and 16 gauge. Well, here's an example. There's a spool of 14 gauge, 100 feet, and then just to give you a comparison, here's the same spool of 16 gauge, same length. So 100 feet, 16 gauge, 14 gauge. Spool is probably twice as big. What you want to try to get away with is the smallest diameter wire for whatever circuit that you're trying to run. There are an abundant number of charts out there that you can use to figure out which size wire you need for a circuit. The way to go about that is, first of all, you have to sum up all the components that's going to draw power on a single circuit. So let's use the tail light thing again. Say you have the tail light bulbs. Let's say we're going to put the reverse lights on as well for good measure. Oh, maybe I don't know if there's anything else that should go on there or not. Maybe you could put the front running lights on there too, turn signals, I don't know. But whatever the case may be, you want to size these things to where you don't have a ton of things all on one circuit, but at the same time you want to try to fully utilize what you've got. We're going to use LED bulbs in this case. You can look this stuff up and tell for each one of the components that you're using how much current draw there is, and you have to add all those up. So let's say all in all we've got, we'll call it 6 bulbs, and they're going to draw 1 amp, or I'm just using that as an example. So what you would do then is estimate how much wire you've got between the fuse panel where you're running the circuit from out to all of the bulbs in this example. Let's call that, I don't know, 20 feet. We're going the length of the vehicle. What you would need then is a wire that supported, we'll call it 5 amps. It's probably the smallest fuse that would be running. Let me look and see on this fuse panel. No, it's hard to tell what the smallest fuse in here is, but let's call it a 5. Yeah, it looks like a 5. So let's say we're running a circuit for a maximum of a 5 amp draw, and we have a total of 20 feet. Well, there's a chart that's going to tell you, okay, 5 amps, 20 feet I need, and I'm going to guess it's we can still get by with a 16 gauge wire. Now don't quote me on that, use the chart, but if the chart says you can get away with that, then use the 16 and not the 14, because 14 is going to be bigger, it's going to cost more, all the stuff, right? And then on the circuits that you do need the bigger wire, and the more amperage that you start to draw on the 10, 15, 20 amp circuits, and the length obviously has a big factor as well, then you can use the bigger wire. On the shorter circuits, ones that you only have, let's say something underneath the dash that may have a considerable current draw, we'll call it 10 amps, but you've only got a total of 3 feet of wire involved, then it may still work on a 16 gauge wire as well. So again, use that chart and just run the wire that you need. I was able to take and buy a whole set, 1, 2, 3, 4, 5, 6. So there's 6 spools, 600 feet of 14 gauge wire, and they come in all different colors. And then I ordered the same thing in 16 gauge. So I've got 600 feet of 14, 600 feet of 16. I think all in all that was probably, I'm wanting to say 60 and 30. So somewhere around 90 bucks. And I've got, 1,200 feet of wire. Now, if I use that properly, I'm gonna have a lot of wire left over, most likely. I haven't gotten into the thick of it yet, but I've pulled my share of wiring harnesses out of vehicles, especially old vehicles, and there's not 600 feet of wire in those, far from it. So you make that investment once, and you're going to have enough wire stock for future projects as they come about. If you want to cut it a little bit shorter than that, you could start with lesser on the bundles. What I have found is there's a point where the cost trade-off is not there. So for example, if I cut this order in half and only ordered 300 and 300, the price wasn't necessarily linear. I was going to pay a little bit more per foot for half the amount of wire, just simply for the cost of the packaging, whatever the case may be. So I went ahead and just again did the 600 feet packs, which is 6 rolls of both 14 and 16 gauge. There will be some one-offs where you're probably going to need a bigger wire. For example, the feeders is going to be much bigger, and again you'll have to just figure that out on the length versus the total number of amps. And in my case, I just ordered I forgot which gauge it was, 6/8 gauge, and they had a negative and a positive in the well, it was 2 different wires, but it was part of the same. It was kind of like the whole lamp cord deal where you pull on it and it splits down the middle, and that was going to be my feeder for one of the positive and one for the negative here, and I think that'll work well. So that's what I would do in the way of wires. There's some other things related to wiring that you're going to need. Connectors is a big one. These old trucks used to have what was called bullet connectors, and I really like those because they're individual connections per wire, so you have a male and a female, and you want to put these connectors near the components. So for example, I've already done the turn signals in this thing, and the wires have been cut near the turn signal, and I'm still working on that. So I put an auxiliary turn signal in for the time being. Of course, they've just got a pigtail of however many wires there was, and that is what I would consider a component, a swappable thing in case it ever goes bad. You want to be able to disconnect a connector somewhere in a modern vehicle to be able to replace said component. In this case, what we're doing is we're putting bullet connectors on each of the wires, and then same concept. If we have to get in and replace a component, there's going to be connectors near that we can just unhook to be able to take that component out. I do not recommend using these just to put 2 lengths of wire together. Now, if you just absolutely have to, you don't have enough wire to run, dedicated circuits where you've only got one single continuous run, then you could do this in a pinch. But you should see this. I mean, every old vehicle that I've ever worked on has been like this. You've got 137 butt connectors that make up the wiring system. You've got taps. You've got, oh, it's just awful. And everybody's done it. And I know I can say this without a shadow of a doubt because of my 30, 40 years of messing with cars. It's been on every one that I've ever worked on, and I can't stand it. So with all that being said, we're doing all this from scratch. We're going to try to keep our wires continuous and not have one of these scenarios where we guess on wires and then we're too short, now we're going to have to connect it with a connector. So try to avoid using connectors just to connect two lengths of wire. Always use these things near components, again, that you would need to swap in or out. These things I really like because they're heat sensitive. So what you do is you still crimp them, and there's a special crimper that I got for these things, which works pretty good. And then once you crimp it, instead of, in the past, what I would have done to make an old school crimp more modern, more secure, safe, whatever, is I would have just put a little length of heat shrink tubing over it and shrunk it. Well, these connectors essentially have that built in, which I think is absolutely fantastic. So you put the wire in there, you crimp it with your crimper, and then you just take your heat gun and heat this end here that the wire sheath goes in, and it just melts to the wire, and of course goes down to where it's all uniform in diameter, and it's just great. Same thing on the female side. And then you've got two clean connections that you just put together just like so, and you've got a bullet connection. Highly recommend. Got these a pack of, I don't know how many is in there, 100 pieces. China again. It says household appliances. I guess you could use that in several different areas, but in this case we are using them from Automotive, and I can say that they work great because I've already started doing some of that work and I've had no problem with them whatsoever. I think that 100 pieces means that there's 50 and 50 male connections and 50 female connections. So don't think that you're going to put 100 connections together. You're only going to put 50 together because you need one of each in order to do that. The next thing I will show you that I got is some wire loom. I got the 1/2 inch. This is the first time I have used this stuff, and I really like it over the plastic that you would just get like if you went to AutoZone, or I mean that's better than nothing. The little plastic loom, which I probably would have if I had thought to look to use as an example, but you know what I'm talking about. It's plastic. It's got a slit down it where you can just, once you get all your wires run, you just stick it all in the crack there, which puts it in the loom, and then typically take black tape and wrap around it then to create your seal. This you see in cars from the factory sometimes, and I thought I would give it a try. It's this mesh, and you can put your wires in the end of that. But the one thing that you may not be able to tell just by looking at this on the surface is actually it can go much bigger than this. So when you push it together, you can get a lot of wires in there. So I think this part is when it's not pushed out like this, it measures a 1/2 inch. It looks like it probably is. This obviously is much bigger than that. I I haven't put this much wire in one of these yet to be able to tell if that's a safe thing or not. But you know, this mesh is really nice and it looks good, and it's really not that expensive. The only thing that I haven't quite figured out yet is after you cut it, then it gets frayed on the end, and I keep thinking that this is just going to keep unraveling, kind of like rope does when you cut it, you know, and you typically will take a flame and melt it on the end to keep it from fraying further. I haven't tried to put a flame to this stuff, but I'm guessing that's not how you do it on wiring loom. Certainly wouldn't do it with wires in there. So what I've been doing is just on the ends, once I get everything in there that I want, is I just take some black tape and just put it on the end, and then that'll, you know, keep that. But I mean, I don't think that that's going to unravel or fray. I mean, it might continue to get a little worse on the end, but it's not going to like come apart to the point where, you know, I just think it's more tidy, and there's a better chance of it staying together and looking neat if you just take a little piece of black tape once you get all of your wires in there. And then if you have to come back and put another wire in there at some point, just take your little piece of tape off the end of it and replace it once you're done. And there you have it. Kiko expandable sleeving. This again is 1/2 inch, and it comes in a 100-foot roll. So I like that stuff. Going back to the barrel connectors, I don't know if I needed this thing or not, but it was fairly cheap. I think it was about 20 bucks, and it provides these square, flat things here to be able to do a compression. So you've got your 3 sizes, red, blue, and yellow. Red being the biggest, blue being mid, and yellow being the smallest. The blue ones were 14 and 16 gauge wire. So my guess is the red would probably be 10 and 12. And then the yellow would be 18 to 20. Again, that's a guess, but I'm sure maybe there's some instruction there somewhere. I think that was probably a good guess because it says right there, AWG 10 to 20 across the range there. So anyway, that was a good investment. One small tip on this thing is there is, according to the internet, a correct way to do a crimp. I don't know if there is or not. I mean, I saw videos of what somebody was calling the right way, and then they did the same crimp the wrong way, and there was a difference, at least the way they were able to illustrate it in the 2 crimps. So I'll just pass along what I saw. On these connectors, if you look in the end of it, the metal piece, the metal barrel that's in there, it comes together. So there's a point in there where I mean, it's not a completely round, there's a slit in the connector where, you know, I guess it started out as a flat piece, and then it's made into a round piece, and then you've got that slit that is touching there. That's, you want to see where that's at. So look in the end of your connector, and just before you ever put the wire in it, just make sure that slit is pointed down. Okay. Go ahead and then put your wire in it. Don't be twisting and turning on, you know, the barrel in your fingers. Keep the slit down, pointed, you know, to the floor. And then when you put it in, make sure that the slit goes in the bottom of the crimper. And that goes for any crimper. I mean, that even goes for these old school crimpers like this. Well, this is probably a bad example. No, it's not. So you've got the crimper here. So you've got the you know, the dip, and then you've got the other side that's the point. Well, the dip, the my words, they're gone. The gully, the whatever you want to call it, that goes, the slit goes in the bottom, in that slot. And then the part, which in this case is more of a round point. In this case, it's, you know, square. That compresses the top. And then in doing that, somehow that slit then creates that nice little crimp, and supposedly will hold the wire better. Look up the video I'm talking about. You'll see it, and it'll probably convince you to do the same. So that's what I've been doing, just making sure that slit in the barrel connector is pointed down, and then just lay that in the bottom of my crimper. What else are we going to need? I got was at Walmart the other day. Got some more heat shrink tubing. They had it marked down for whatever reason. Of course, I bought that up. You never have enough heat shrink tubing. On the flip side, you have a Harbor Freight in your area, or one of their competitors. They've got their version of assorted heat shrink tubing. You can never have enough of that stuff. I haven't given you an example yet of where I would use heat shrink tubing like that, but trust me, when you're in there wiring, you will find something that needs some heat shrink. This is something else, and these are the traditional connectors that you see 147 of used in old vehicles where people piecemeal wiring together. I typically stay away from them. They're basically just your crimp only connectors. I hate them with a passion. Hate them with a passion. With that being said, I did not have any other option, and I need to look on Amazon. I bet there is some of these connectors with the heat shrink built in, but then on the other end has these ring connectors, which is useful anytime you've got a connection you're putting a screw through, i.e. the fuse panel. So this is going to go, you know, here, and your screw's going to go through there. And I needed some of these in a pinch. So what I did is, since I did have to use some of these, I just took and made my own. You know, I think I referred to that earlier. I put a piece of heat shrink tubing over the wire, and then put this dude on, crimped it, and then brought the heat shrink tubing back up over to where it fits over this plastic piece, and heated that up and shrunk it all together. I think I've got a video, a short on the channel that shows an example of that in action. But in a pinch, that's what you can do. I don't use any of the other of these things in here. I'm not even going to show them to you because I hate them. You know, the splice, and just you know, and there's your traditional barrel connector. You've got a gazillion of them things all over. I said I wasn't going to show them to you, so I'm not going to do it. Don't use them. Don't use them. They're bad. I don't want to see them. The one other thing that's pretty cool, these are from Harbor Freight. I do not have the label on them anymore, but if you have to drill any holes through panels, firewall, whatever the case may be, these will make the job look so good. You basically have a set hole that you need to drill, and that's where that label, I don't know where it went, but that label will tell you for each one of these sizes what kind of hole what kind of drill bit, size drill bit you need to use, and then you stick that grommet in there afterwards, and now you've got a very clean through the firewall or whatever panel pathway that's not going to strip or nick your wires when you push them through, or rub, vibration, all that. So those things you definitely need. I've used several of them already. These are just some cutters, otherwise people call them dikes. I think these were Harbor Freight Specials. I don't know. There's some needle nose pliers. They're probably useful for something in this job. What else do I have? Oh, this is the most important tool that you'll need in the whole thing. This is my trusty multimeter. It was given to me one year for Christmas. Just a craftsman job. Probably wasn't more than 50 bucks, and that is going to be invaluable for your wiring journey. The two main things that you're going to use on it is an ohm meter to test continuity, or in some cases maybe resistance, and then the other is going to be DC voltage. Oh, one other thing that I did not mention: a heat gun. Hair dryer, I don't think I haven't seen one that gets as hot as this thing does, which is great. This one actually has both a heat and a cool. You press this button and it turns blue, and see, there's a red, and then there's a blue. So it's pretty nice where you can obviously bring the heat to it with the red setting, very hot. Again, much hotter than a hair dryer. And then before you touch it, which is you don't want to touch it right after you use this thing, because it will feel like a burn. You can immediately switch it over to the blue setting, and it'll blow some kind of air on it that's not hot. I'm not going to dare call it cool, but it's cooler than the heat setting. This one is older than the heels, so you probably will not find one exactly like this one. Polyflex Universal Model 500 electric heat gun. This thing actually was in part of my uncle's estate, and he built remote controlled airplanes back when they still were gas engines. And you build the plane body out of balsa wood, and then there's some sort of covering that you put over the body and the wings, and that covering has to be connected or sealed or whatever using heat guns. And this one was part of that collection estate that he had, and it works really good. But I think you'd probably be best to invest in something like that. I don't believe you're going to get a hair dryer that hot, because you need it to the point where if you stick your finger under it, it's going to feel like a burn. So take a look at those as well. I mentioned these fuses weren't going to fall out, and I see one that's fell out. But listen, the one that fell out, it's the ones that's for the spare. It's because there's no metal connector in it that's holding on to the thing. So it's just a plastic setting in there. So it did fall out, but I'm not gonna lose any sleep over that. Okay, I think that's it. One last thing I'll say that I'm going to do is I'm going to put a breaker between the hot feeder wire of each one of these sections, and you can get those through Amazon. I got one that's called it's by True Mods. It's a 4-pin relay, and you just basically have your big feeder wire in, from your power source, and then your feeder wire out, which in this case would go to your panel. And now you've got a relay that you can control through these connections. So you just wire some sort of connection source up to where this relay connects these two connections together, and now you've got power all the time across there. I would not wire this to continuous power, and the reason why is that will create a constant power drain on your battery, which you do not want. So what you would do is the power that would be run to activate this relay needs to come off of your ignition switch. So basically when you turn the key on, the relay comes on, connects the two feeders together, and powers your panel. Otherwise, you have a constant power that makes this relay stay closed all the time. That's going to draw some minute amount of power, and you let your vehicle sit for a long period of time, that's going to create a drain on the battery, so you don't want to do that. So just keep that in mind as well. I think that's it. So we'll create some other videos that have more detail as we dig into the specific circuits that we're wiring, and hopefully we'll share some of that knowledge with you as we go along. Please like and subscribe. I really appreciate all the engagement, and let me know in the comments what you'd like. If you see something that I've mentioned, or maybe a comment on something that I'm going to work on in the future or not, give me some ideas, and I will be glad to consider that. And if I can make that happen, I'll put it on the list of future videos to make. Thanks.